In the 1840s, astronomers had been tracking the planet Uranus, which was discovered in the late 1700s, for several decades. And they realized that its orbit was off. Something was perturbing its orbit, and they went on a search for a new planet. And they calculated on a sheet of paper the mass of that planet and its location. That planet was called Neptune. Well, guess what? After a few more decades, astronomers decided that Neptune's orbit was off and there was something perturbing its orbit. Thus began the search for Planet X. Now, the funny part about that is their calculations were way off. There wasn't going to be some large object out there perturbing Neptune's orbit, but it didn't matter because the search had begun. Okay, that search was led by Percival Lowell, a wealthy Bostonian who'd moved out to Arizona and founded the Lowell Observatory. Now, they're looking for an object like, let's say, 5 times the size of Earth, right? And they end up hiring a Kansas farm boy named Clyde Tombaugh. Clyde Tombaugh. Boy, Clyde had a rough job. He had to sit there day after day in front of this machine called a blink comparator. And they would take a picture of the sky on a glass plate, and then maybe a night or two later, they'd take another picture of the same patch of sky. And what are you going to see? You're going to see a bunch of dots. And those dots are going to be lined up exactly the same because in a night or two, you're not going to notice any stars moving. And you're just looking for one dot that moves. But guess what? The dots never move. Night after night, day after day, he's putting these plates, this comparator would put them on top of each other. He'd never see a dot move. Imagine how frustrating. Never getting positive reinforcement, any kind of positive feedback, day after day after day. He does this for over a year, looking at thousands of plates, hoping one day one of those little dots is going to move. And guess what? After a year, it finally did. And it was big news. It was huge news around the world. And I think especially in the United States, because of the first American to discover a planet. But keep in mind, they were way, way off. Look at this headline here, greater than Earth found. Ooh, well, no. Anyway, this new object needed a name. And Pluto is the god of the underworld, which makes some sense. You're out in this cold, dark region of the solar system, right? So that's why they went with the god of the underworld. But the funny part about that was who actually proposed the name, and that person was an 11-year-old girl pictured here. She lived in Great Britain, mentioned the name. She was studying mythology, I guess, in school, and mentioned that idea to her grandfather, who knew an astronomer, and somehow it made it out to Arizona, and they voted to name it Pluto. At the same time, then, a young man named Walt Disney needed, I guess, a pet for his cartoon mouse, and so Pluto the dog apparently was named after Pluto the planet. One other thing that was named after Pluto, by the way, you don't think about this much, but a lot of the elements on the several elements on the periodic table, I should say, were named after elements, from Mercury up to uranium, which we never think about, is named after the planet Uranus. Neptunium, and there it is. You got to keep following suit there. So when they discovered Pluto, we ended up with plutonium. Plutonium, kind of cool, right? Of course, we use uranium in nuclear reactors, and we use plutonium, of course, for building time machines out of DeLoreans. But of course, you have to have a flux capacitor and 1.21 gigawatts to get that to work. So it's just good science. All right. For about half a century, Pluto's in great shape. Nobody's having this discussion of whether it's a planet or not. They for that time period, they pretty much thought it was probably something comparable to the Earth in size and mass and so forth. I think really the beginning of the end for Pluto as a planet occurred in 1978. You would think discovering a moon around Pluto would be a bonus, a positive. It makes it sound more planet-like, right? But with the discovery of Charon, now we had a very easy way to calculate finally an accurate mass for Pluto, right? As Charon orbits, it's just high school math to get a good estimate there. And so it turns out it wasn't the mass of Earth, or 10% the mass of Earth, or 2% the mass of Earth. It was 0.2% the mass of Earth. And I think that really changed the thinking, probably of a lot of astronomers. And over the decades, we also began to realize it wasn't nearly as big as first imagined. We now know it's actually quite a bit smaller than Earth's moon. Here you see Pluto and Charon over the United States there. By the way, the other thing about Charon is that, our Earth is about 81 times, I think, the mass of the moon. Pluto's only about 6 times the mass of Charon. And what that means is that actually Charon doesn't orbit Pluto. It's so massive compared to Pluto that they both orbit a point called the barycenter outside of Pluto. So instead of one object just sitting there going around the other, both objects are orbiting this common point in space. So probably whatever you call Pluto, you should probably call Charon the same thing, a double planet or double dwarf planet or whatever. Just throwing that out there. Anyhow, I always think that part of the reason it took a while to have this discussion, at least in the 1990s, I always felt bad because Clyde Tombaugh was still alive. He lived like into his 90s, and he would be in the videos we'd watch in class. I just felt bad for him because he was getting upset when that discussion, you leave my planet alone, that kind of thing. I was like, oh, come on, let's back off a little bit. But I do want to mention that it's not just about the size of Pluto. There are other factors. When I used to teach this years ago, and it was still considered one of the 9, the inclination of the orbit is different. The other planets, the 8 classical planets, are going around in a flat plane, and Pluto's orbit is tilted by 17 degrees, which made it kind of an oddball. The shape of the orbit. The other planets in our solar system, anyway, have very circular orbits, and Pluto's was stretched out. It was elongated, what we call eccentric. So it never did quite fit in, just to be honest. When I used to teach it, and you'd have the 4 rocky terrestrial planets and followed by the 4 gas giants, and then you had this icy object out there. But that really, oh, there it goes. There's my little GIF there. But that really started to change in the 90s and early 2000s with the discovery of other icy objects with it, like Quaoar and Sedna. And so it became very clear, no matter what you called it, definition-wise, that Pluto was part of the Kuiper Belt. No doubt about that. It belongs with this icy debris out there, and because it's not as flat, it's more of a donut shape, you can have the inclined orbits and the more eccentric orbits and so forth. And so Pluto really fits in out there. Doesn't mean you have to call it a planet or dwarf planet or whatever, but that clearly was sort of its home. Now, one person did decide to go ahead and make the move all the way back in 2000 after we started discovering these other things. The director of the Hayden Planetarium, a man named Neil deGrasse Tyson, you may have heard of, he went ahead and made the move. And by the way, I highly recommend the Hayden Planetarium. It's a great place to visit there in New York City. It's part of the Natural History Museum. And anyway, yeah, he just removed it in the year 2000. He just moved it, and people were upset about it and so forth. And that really that really got the discussion going, I think, in the public's mind. And you could see he wrote the Pluto Files about that later on. So we found Quaoar, we find Sedna, we keep finding objects getting up closer and closer in size to Pluto, and you knew it kind of had to happen, and it finally did in 2005. Astronomers discover an object that's basically Pluto's twin. Caltech astronomers, led by Mike Brown, discover Eris. Eris is round. It's big enough to be round. It's, it has a moon. It's the same size and mass, roughly, as Pluto. Yeah, that really forced the discussion. And that discussion came pretty quickly. So just the very next year, the IAU is going to have a talk. And here are some of those other objects out there in the vicinity beyond Neptune, right? You have to have the discussion now. It forced it. And so in 2006, the IAU, the International Astronomical Union, they have this conference in Prague. And I remember thinking halfway through the week that we might end up with a solar system with 11 planets, that they would go ahead and make Eris a planet, and the asteroid Ceres, which is also big enough to be round. And the pendulum was swinging that way, I felt like. And then by the end of the week, it swung back the other way. And on the very last day, they voted to create a new category called dwarf planet. And Pluto then would be sort of demoted, I think, in a lot of people's mind, from planet to dwarf planet. So the exact definition that they came up with, like it or not, was this: that first of all, you have to orbit the sun independently. That way it leaves out moons and things like that. Part B just says it has to be round. Okay. If you meet parts A and B, you get to be called a dwarf planet. So that's why the asteroid Ceres, for example, gets to be called a dwarf planet now. But the third part, that's the key. All right. Has cleared its neighborhood. Cleared the neighborhood. In other words, if you're inside the asteroid belt like Ceres, or you're inside the Kuiper belt like Eris and like Pluto, then you don't get to be called a planet. Is that fair? Leave that up to you to decide. Is that objective? Cleared the neighborhood. Yeah, that's really the catch, isn't it? That's kind of the catch that gets a lot of people thinking about that definition. Anyhow, I can tell you this, the public in general, I think, was rather upset. Everybody had grown up with Pluto being a planet. My grandparents could still remember barely, from when they were kids, when it wasn't, when it was first discovered. But everybody on Earth had grown up with the majority of their life Pluto being a planet. People were kind of upset about it. All right. Well, it turns out, though, that the very same year that they sort of demoted it was we finally launched a spacecraft to actually go visit it for the first time. Because even in 2006, you have to understand, all we had were like fuzzy images, blurry images of it, even from the Hubble. And boy, that was exciting. We watched that launch in my class in 2006. The kids were all excited, and they're like, "Oh, when's it going to get there, Mr. Jeter?" And I'm like, "Oh, in 9 years." Ooh, they weren't happy. They didn't. 2015 seemed very futuristic. So anyway, well, when it did arrive, oh man, yeah, it was something special. I mean, to finally see Pluto. First of all, in the meantime, in that 9.5 years, we discovered that Pluto has an atmosphere that you can see there in the light. It has an atmosphere. It doesn't just have Charon, it actually has 5 moons. Okay. And then we get this image, and I knew immediately, like, oh gosh, the public's going to love this, because you have this, well, it's a heart-shaped region on Pluto, right? So people love Pluto, and seeing a big heart on there, I was like, oh man, this is going to bring back that debate big time. But anyway, what's really exciting about that region is that it appears to be like a glacier. Yeah, there's geological activity on Pluto, this small world that far from the sun. God, that is just, I mean, that was not something we could have conceived of a quarter century ago when I first started teaching my astronomy class. I wouldn't have dreamed that you had this complex world. Take a look at this. The team, the New Horizons team, put this together, showing what it would be like to fly over the surface. And you can see the complexity there. And you know that there's been geological activity, and it's just fascinating. And really, maybe the coolest part of all is that there could be liquid water. Yes, there could be an ocean on Pluto. It's just wild. Like, I mean, I think if that's the case, you have to consider Pluto as being one of the top 10 places to look for life in the whole solar system. Again, I can't even believe I'm saying that, because 25 years ago just would be completely unexpected. So, bottom line is, and I was making this video, I don't think you can hear me talking in it, so I'm just going to say what I was saying in this last little clip here, if I can get to it. Oh, well, I'm sorry. I have to show you this first, though. Look at this. This was the picture they took after New Horizons flew by, and they looked back at it. And it just puts a big smile on my face every time, because wow, it's a real place. It's a real world. It's not this fuzzy little image anymore. You have mountains of ice, and you have glaciers, and look at the layers and the atmosphere and complexity. And so I guess the bottom line is, whatever we choose to call it, whatever the semantics are, planet, dwarf planet, whether we tighten up that definition or not, it's an amazing place. It's just it's going to be a great place to explore. I hope I live to see us go back there and find out more, because I think it holds answers to questions about, geology, especially on a smaller world like that, about the formation of the solar system, especially beyond Neptune, and even possibly teach us things about life. I mean, it's an amazing place, and definitely worthy of our study and our interest. Thanks for listening.